Good morning, class. Today we are here to do the revision of our chapter 2, that is whole number. So let us understand the basics. We all know what kind of numbers are there. The very first set of numbers contains natural numbers. So natural numbers we can have from 1, 2, 3, and it goes till infinity. Then we are having the other set of the whole number where along with the natural numbers we are having 0 as well. So 0, 1, 2, 3 till infinity, it will make a set of whole numbers. In other words, we can write whole numbers is a set where natural number along with 0 form a set. So we can say that every whole number is a natural number except 0. 0 is not a natural number. So this is one of the basics. Now let us move to what operations we can do on whole numbers. We can go for addition for whole numbers. Whole numbers means like 2 plus 3. So answer would be 5. Subtraction, 5 minus 3, answer would be 2. Multiplication, multiplying 2 into 5, you will get 10. Division, 10 divided by 2, you will get 5. So all the basic operations can be performed on whole numbers. Now our next topic that we are going to have is, very important topic is this, properties of whole numbers. What all properties are there, which can be seen in whole numbers. The very first property is commutative, closure property. So the first property is the closure property. Closure property means if we add or multiply any two numbers, any two whole numbers, the answer would be a whole number. For example, if I add 2 plus 4, I will get 6. So this is a whole number, this is a whole number, and this is also whole number. Alright, second thing, for multiplication we can see. So 2 is a whole number, 4 is a whole number, and 8 is a whole number. Therefore, we can say that closure property holds true for addition and multiplication, but not for subtraction. Why not for subtraction? Because when I subtract any two whole numbers, let us say 5 minus 6, I will get minus 1. No doubt, 5 is a whole number, 6 is a whole number, but what about minus 1? Minus 1 is not a whole number, it is an integer. Therefore, the closure property does not satisfy for subtraction. Likewise, it does not satisfy for division. In division, we can see the example. 4 upon 2 will give you the answer 2. So obviously this is whole number, this is whole number, this is also a whole number. But what if I reverse it? 2 divided by 4. It will give 1 by 2. That is 0.5. Again 0.5 is not a whole number. So when I subtract and divide any two whole numbers, they may or may not be the answer is a whole number. It can or it cannot be. Therefore, it does not hold true for the closure property. So that is one of the very important thing. Second property we are going to see here is commutative property. Whenever the word comes commutative, you always remember that it is related to the order of any two numbers. Now, here we can see there are two numbers, A and B. I added them and then I added them in a reverse order, B plus A. Still, I will get the, my sum would be same. We can see the example. Either I add 2 plus 3 or I add 3 plus 2, I will get 5. Alright, so commutative property holds true for addition, but again it does not hold true for subtraction. because 2 minus 3 will give you minus 1, whereas 3 minus 2 will give you plus 1. So they both are not equal. Commutative property holds true for multiplication as well. So as you can see here, 2 into 5 or 5 into 2. We have changed the order but still the product is same. That means commutative property holds true for multiplication. But will it hold true for division? Let us see. No, it will not hold true for division, because when I divided 4 by 2, I got the answer 2. But when I change the order, that is 2 upon 4, the answer is 1 upon 2. That means from this we can conclude commutative property holds true only for addition and subtraction, addition and multiplication, not for subtraction and division. That was all about the second property. Now let us come to the third property, that is associative property. Now, whenever we talk about the terms associative, it is related to three terms. There should be three numbers. For example, if I have now, what this property says, if we arrange the numbers in any of the order, if there are three numbers and we add them in any of the order, like in the LHS you can see, first I did A plus B, then I add the sum to C. But on the RHS what I did, I added B plus C and then I added the sum to A. But from both the cases answer will come same. So this is associative property. It holds true again for addition and multiplication. That means in any order you can multiply them, you will get the same product. In any order you add them, you will get the same product. But again, it does not hold true for the subtraction and division, as it was not true in commutative property. Now, the last property that we are having for distributive property. Distributive property is very important for this chapter in class 6 because many of the questions are based on this property. Now, distributive property says this is basically multiplication over addition. A multiplied by B plus C. A multiplied by B plus C is equal to, if I multiply A into B, plus A into C. A multiplied by B plus C is equal to A multiplied by B plus A multiplied by C. Why we are calling it distributive? Here you can see when we are opening the bracket, this A is being distributed over B and then it is distributed over C. Why we are calling it multiplication over addition? The first symbol that we are having multiply, we are multiplying on the sum, that is of B plus C. So I hope this is clear. Its example we can see, let us say if there is any number 10 multiplied by 2 plus 3. So whatever the answer will come, that is 10 into 2 plus 3 is 5. Answer will come 50. The same way you can also solve it like 10 into 2 plus 10 into 3. That is 20 plus 30 and the answer will be 50. So you can apply this identity or I can say property in any of the form to make your calculations easier and simpler. I hope all the properties are clear to everyone, and these are going to help with the further questions in this chapter. That's all for today. Thank you.